Okay, so I want you to do something for me. Close your eyes for a second. And just picture the human body. You have this incredibly complex, intricate network of veins and arteries.
Right. Miles of them.
Miles of them, carrying life to every single extremity, from your brain down to your pinky toe. It's a system we just ignore it completely.
We don't even think about it, not until there's a blockage or worse.
Exactly. Or a rupture. And when that system fails...
Oh, it's usually catastrophic. It stops being background noise and becomes the only thing that matters.
Right. Now, open your eyes and just look at the wall nearest to you. Behind that dry wall, your home has the exact same thing. A vascular system. Moving water, removing waste, regulating temperature. And just like our bodies, we tend to ignore it.
Until water starts pouring through the ceiling.
Precisely. It's the invisible infrastructure.
Yeah.
We obsess over the fixtures, the brushed nickel faucets, the farmhouse sinks.
But we rarely think about the veins delivering the water to those pretty objects.
Well, today, we are metaphorically ripping down the drywall. We are going to expose that infrastructure. But we aren't talking about the rusted iron pipes of the 1950s or even the copper that's been the gold standard for decades. We are doing a deep dive into what the data says is the new king of the hill, the Uponor PEX piping.
And specifically, a material called PEX-a.
It's a fascinating topic because it sits right at the intersection of, advanced chemical engineering, macroeconomic trends.
And honestly, just the peace of mind of anyone who owns a home.
That is the mission today. We want to move past the idea that pipes are pipes. We've combed through industry reports, technical specs, and market analysis to figure out why this flexible plastic tube is being called a game changer. We're going to cover everything from the molecular engineering, which is surprisingly cool, by the way.
It really is.
To the hard math of what it costs to gut a house and install this stuff.
And it's a massive shift. I mean, we are effectively watching the construction industry move from the Iron Age into the polymer age.
So let's start with that big picture. We see this massive market trajectory in the research. The global PEX market is projected to nearly double, jumping from, $2.2 billion in 2025 to $4.2 billion by 2035.
Yeah.
That is not a small blip. That's a takeover.
It is. And to understand why that money is moving, you have to understand what this stuff actually is. PEX is just an acronym for cross-linked polyethylene. It's a type of plastic. But the cross-linked part, that's the secret sauce.
Right. I was reading about the standard polyethylene, like what a grocery bag might be made of. It's kind of like long strands of spaghetti just lying next to each other.
That's the perfect analogy. They're separate.
But cross-linking ties them together.
Exactly. Imagine if you took those strands of spaghetti and tied little knots between them all, creating a net. That is what happens at the molecular level. It turns a standard, flimsy plastic into something much stronger, much more temperature resistant, and much more durable under pressure.
And Uponor specializes in PEX-a.
Right, which is one specific way of making this net.
And the A matters, doesn't it? It's not just a grade, like getting an A on a test.
No, not at all. It refers to the manufacturing process. It's called the Engel method. See, there's PEX-b and PEX-c, which are made differently. They often cross-link the material after it's been shaped into a pipe.
Okay.
But PEX-a is made by cross-linking the polymer while it's still in its melted state. This creates the highest degree of cross-linking, around 85%. And that uniformity, it gives it properties that the other types just don't have.
Which is how they can position it as the premium product in the market.
Spot on.
And clearly the market is buying what they're selling. But looking at the drivers for this $4.2 billion surge, it's not just about new builds, is it?
No, not at all. The research points to a massive wave of retrofits. That's a huge factor.
So old houses.
Think about the housing stock in the U.S. and Europe. You have millions of homes built in the 50s, 60s, 70s. They used galvanized steel, which rusts and constricts flow, or early copper that is starting to develop pinhole leaks.
So those systems are reaching the end of their biological lifespan, so to speak.
It's like the arteries hardening.
Yeah. And if you're a homeowner facing a repipe, you're looking for the path of least resistance. You don't want to tear your house down to the scuds if you can avoid it.
Precisely. And this is where the tech innovation comes in. Uponor isn't just resting on the pipe they invented 30 years ago.
The notes mention ServicePEX, which just rolled out in late 2024.
That caught my eye, too. It's specifically designed for large diameter service lines, bringing water from the street to the building.
So they're not just thinking about the bathroom anymore.
They're thinking about the whole grid.
But what's even more interesting to me is the sustainability angle. I feel like plastic and eco-friendly usually don't belong in the same sentence.
It is counterintuitive, I get it.
We're conditioned to think plastic is the enemy. But the data here suggests otherwise.
Well, you have to zoom out and look at the life cycle. Think about copper. To get copper pipe, you have to mine ore, crush tons of rock, smelt it at incredibly high temperatures, and transport these heavy metal coils across oceans.
It's incredibly energy intensive.
Very. But Uponor is now producing PEX using renewable raw materials that, according to the life cycle analysis, slash the carbon footprint of manufacturing by up to 90%.
90%. That is a staggering number. That's not a margin of error. That's a revolution in production.
It is. And in commercial builds, we're seeing hybrid systems. They're mixing PEX-a with CPVC and other rigid plastic to handle different chemical environments. It's about using the right engineered material for the right job rather than just defaulting to metal because...
That's how we've always done it.
Exactly.
So we have a booming market. We have advanced chemical engineering, a sustainability argument. But I want to bring this down to the ground level. Let's say I'm listening to this and I've just bought a standard 1,500 square foot fixer-upper.
Okay, congratulations on the headache.
Right, thank you. But the inspection report comes back and says the plumbing is shot. I need to replace it. What does that experience look like with Uponor PEX compared to the old days?
Well, first, the shopping cart looks very different. You aren't buying 10-foot rigid sticks of metal that you have to strap to the roof of a truck.
You're buying coils.
You're buying coils. Uponor PEX comes in big rolls, red for hot, blue for cold, and white or clear for neutrals.
Which is a huge usability upgrade right there. Yeah. No more guessing which pipe burns you when you touch it.
It simplifies the schematic, exactly. Then you have the manifolds. In a traditional system, you have a big trunk line with branches coming off it everywhere. It's a tree structure.
Okay.
With PEX, you often use a home run system. You install a manifold, basically a distribution center near the water heater. Every single fixture in the house gets its own dedicated line running directly from that manifold.
Oh, like a circuit breaker box, but for water.
Perfect analogy. If the kitchen sink leaks, you just flip a switch at the manifold and kill that one line.
But the rest of the house still has water. You can still take a shower while you fix the sink.
Exactly. It's a luxury you don't appreciate until you need it.
But I want to talk about the connections, the fittings. This, to me, is the most interesting technical difference. The research highlights the ProPEX expansion fitting. How does that work?
This is the game changer for PEX-a specifically. If you use, say, PEX-b or other generic tubing, you usually use a crimp fitting. You slide a metal ring over the pipe and you just crush it down with a tool. It works, but...
You're restricting the water flow, right? Because the fitting goes inside the pipe, making the opening smaller.
Exactly, and you're relying on that crushed ring to hold forever.
Okay.
Uponor's method is completely different. Because PEX-a is so flexible, you use a specialized expansion tool. It looks like a power drill with a cone on the end. You put a plastic ring on the outside of the pipe, you stick the tool in, and you pull the trigger. The tool actually stretches the pipe and the ring open.
So you're physically widening the tube.
You widen it just enough to slide the fitting in. Then you take the tool away. And because of that molecular net we talked about, the plastic desperately wants to return to its original size. It shrinks down, biting into the fitting with thousands of pounds of force.
So the pipe itself is the clamp.
Yes. And here's the kicker. As hot water runs through it over the years, that seal actually gets tighter.
No way.
It's a dynamic seal, whereas a copper solder joint is static. It's just sitting there.
That brings us to the property that the sources call the memory factor. This was the aha moment for me reading the notes. You have to explain this because it sounds like magic.
It's thermal memory. And it's unique to PEX-a.
So what happens if a contractor is dragging a coil around a corner and accidentally puts a hard kink in the pipe?
If that's copper, you're cutting that piece out and throwing it in the scrap pile. It's ruined.
Done.
Even with other plastics, a kink creates a weak spot, a stress fracture.
But with PEX-a...
With PEX-a, you stop. You pull out a heat gun, like a really high-powered hairdryer, and you just heat up the kink. As the plastic hits a certain temperature, that molecular structure resets. You literally watch the kink disappear and the pipe turn back into a perfect cylinder.
Right before your eyes.
Right before your eyes. It heals itself. Then you let it cool and it is just as strong as it was before.
That has to translate directly to waste reduction and speed on the job site.
Right.
But magic self-healing plastic sounds expensive. Let's talk about the hard numbers. My 1,500 square foot house. Am I paying a premium for this tech?
Surprisingly, no. You're actually saving money, primarily on labor, but the materials are competitive too. Let's break down the material cost first. For that size house, you probably need 500 to 1,000 feet of tubing. PEX runs anywhere from, say, 40 cents to $2 a foot, depending on the diameter.
So the actual veins of the house might only cost, what, $500 to $1,000?
In raw pipe, yeah. Then you add the manifold, the ProPEX rings, the brass elbows for the walls. Your total material bill is likely landing between $1,500 and $3,000.
That seems incredibly reasonable for a whole house.
It is, but the real savings is labor. Think about running copper.
Oh, yeah.
You have to measure, cut, clean the joint with sandpaper, flux it, assemble it, and then stand there with a torch soldering it, then wait for it to cool.
And you have to do that at every single corner, every turn.
Every single one. And you're using an open flame inside a wood-framed wall. It's risky.
Right.
With PEX, you treat it like an electrical wire. You drill holes in the studs and just snake the flexible tube through the walls. You don't need an elbow for every 90-degree turn. You just bend the pipe.
So you're eliminating hundreds of potential joints.
Exactly. Fewer joints means less time and fewer potential leak points. A crew can repipe a house in PEX in maybe 2 or 3 days. With copper, that could be a week.
Okay, so let's tally it up. Labor, materials, and let's toss in the inevitable permit fees. Usually a few $100.
200 to 500, depending on where you live.
What's the damage for our hypothetical homeowner?
The bottom line for a full repipe usually falls between $4,500 and $8,500. It can go up to $11,000 if accessibility is terrible, like a nasty crawl space, but that's the sweet spot.
And if I insisted on copper, because I'm a traditionalist,
You should prepare to pay double, maybe $15,000 to $20,000.
wow.
Copper prices fluctuate wildly on the commodities market, and the labor intensity is just so much higher.
Okay, so it's cheaper, faster, and easier.
Mm-hmm.
But I have to play devil's advocate here. There's still a stigma about plastic in, luxury homes or even just quality homes. Is it actually better functionally, or is it just the cheap option?
That's the question everyone asks. But when you look at the technical performance data, PEX actually outperforms metal in several key areas that matter to livability. The first is water chemistry.
We tend to think of water as pure, but municipal water is. It's a chemical cocktail.
It is. It has chlorine, minerals, varying pH levels. Copper is a metal. It reacts. If you have acidic water, a low pH, it literally eats the copper from the inside out. PEX is inert to that.
So it doesn't pit.
It doesn't pit, and it doesn't get that scale buildup calcium carbonate that eventually clogs old metal pipes like a clogged artery.
So the flow stays consistent for decades. What about the noise? I saw water hammer mentioned in the notes.
You know that loud bang you sometimes hear in an old house when the washing machine shuts off?
Like someone hit the pipes with a hammer? It sounds like the house is breaking.
That's a hydraulic shock wave traveling through the water. In a rigid metal pipe, that energy has nowhere to go, so it slams into the fittings.
Right.
PEX is flexible. It acts like a shock absorber. It just dampens that vibration. So a PEX house is significantly quieter.
And then there's the big one for anyone living north of the Mason-Dixon line, or really anywhere that gets a frost. Freezing.
This is the killer app for PEX.
Well,
Water expands when it freezes. We all know this. If it's trapped inside a copper pipe, the copper is rigid. It fights the ice, and the ice always wins. The force of the ice splits the copper open like a zipper.
which leads to the nightmare scenario. The thaw and then the flood.
Correct. But remember that molecular net in PEX-a? It allows the pipe to expand. The specs say PEX-a can expand up to 3 times its own diameter to accommodate the ice.
3 times, it just balloons out.
It balloons out. It looks ridiculous if you see it in a lab test. And then, as it thaws, that thermal memory kicks in, and it shrinks right back to its original size.
Wow.
Now, we aren't saying you should let your pipes freeze. It puts stress on the system, and you won't have water. But the failure rate is drastically lower than metal. It's forgiving.
It sounds like the perfect material. But as we know, nothing is perfect. I want to make sure we address the criticisms found in the sources. There's a section here on chloramines and longevity issues. We need to unpack that.
Yes, and this is important for a balanced view. While PEX doesn't rust, it is a polymer. And polymers can be attacked by certain oxidizers.
And chloramine is what cities use to disinfect water, right?
Right.
It's basically chlorine plus ammonia.
Correct. It's more stable than just chlorine, so it stays in the pipes longer, which is good for keeping water clean, but it can be tough on materials. There has been significant debate and, frankly, litigation in the industry regarding whether high concentrations of chloramines combined with high pressure and very hot water can degrade PEX over time.
How does it degrade?
It can essentially make the plastic brittle from the inside.
So is this a theoretical risk or a real failure point?
It has happened. However, it's important to note that this is largely why the standards have evolved. The sources point out that Uponor and other manufacturers have adjusted their antioxidant packages, basically the additives mixed into the plastic, to specifically resist chloramine attack.
So it's kind of an arms race between the water treatment plants and the pipe manufacturers.
In a way, yes, it's not a deal breaker for most people, but if you live in an area with notoriously aggressive water treatment, it's a question worth asking your plumber.
Is this PEX rated for our local chloramine levels?
Exactly.
The other thing hinted at in the research is sunlight.
Oh, absolutely. PEX is a vampire. It hates the sun.
Okay.
You cannot store it outside. UV light breaks down that molecular structure very, very quickly. If you see PEX exposed to the sun on a job site for weeks, that's a red flag. It belongs strictly behind the wall.
Despite those caveats, the lifespan projections are still pretty impressive.
We are looking at a projected lifespan of over 100 years. Uponor backs it with a 25-year transferable warranty, which is one of the best in the business. So assuming it's installed correctly out of the sun and with the right fittings, it is a permanent solution.
So let's recap. We've tracked this from a $4.2 billion macroeconomic trend all the way down to a, 40-cent piece of tubing behind your shower wall. It's amazing how much engineering goes into something we actively try never to see.
And that is the definition of good infrastructure. It works so well you forget it exists. But I think for our listeners, whether you're planning a massive renovation or you just want to understand the building you sleep in every night, understanding this shift is crucial.
It really changes your perspective on what quality means in a home. We're moving away from the heavy and the hard to the smart and the flexible.
It does. It validates that technology in construction isn't always about smart thermostats and solar panels. Sometimes it's about the chemistry of the pipe in the wall.
I want to leave you with a thought before we sign off today. For centuries, our concept of permanence in architecture was about rigidity. Stone, brick, iron, copper. We thought that to last, a home had to be unyielding.
Hard materials for a hard world.
Exactly. But now, the data is showing us that the things that last the longest are the things that can adapt. A plastic that heals itself with heat. A pipe that balloons out when it freezes instead of shattering.
It's a move toward resilience rather than just brute strength.
It really is. Are we moving toward a future where our homes are designed more like living organisms? Flexible, soft, and self-healing? Does PEX signal the end of the heavy metal era in our homes entirely? It's something to mull over next time you turn on the tap to brush your teeth.
It's a whole new way to look at the walls around us.
Thanks for diving in with us. We'll see you on the next deep dive. Okay, so I want you to do something for me. Close your eyes for a second. And just picture the human body. You have this incredibly complex, intricate network of veins and arteries.
Right. Miles of them.
Miles of them, carrying life to every single extremity, from your brain down to your pinky toe. It's a system we just ignore it completely.
We don't even think about it, not until there's a blockage or worse.
Exactly. Or a rupture. And when that system fails...
Oh, it's usually catastrophic. It stops being background noise and becomes the only thing that matters.
Right. Now, open your eyes and just look at the wall nearest to you. Behind that drywall, your home has the exact same thing. A vascular system. Moving water, removing waste, regulating temperature. And just like our bodies, we tend to ignore it.
Until water starts pouring through the ceiling.
Precisely. It's the invisible infrastructure.
Yeah.
We obsess over the fixtures, the brushed nickel faucets, the farmhouse sinks.
But we rarely think about the veins delivering the water to those pretty objects.
Well, today, we are metaphorically ripping down the drywall. We are going to expose that infrastructure. But we aren't talking about the rusted iron pipes of the 1950s or even the copper that's been the gold standard for decades. We are doing a deep dive into what the data says is the new king of the hill, the Uponor PEX piping.
And specifically, a material called PEX-a.
It's a fascinating topic because it sits right at the intersection of, advanced chemical engineering, macroeconomic trends.
And honestly, just the peace of mind of anyone who owns a home.
That is the mission today. We want to move past the idea that pipes are pipes. We've combed through industry reports, technical specs, and market analysis to figure out why this flexible plastic tube is being called a game changer. We're going to cover everything from the molecular engineering, which is surprisingly cool, by the way,
It really is.
to the hard math of what it costs to gut a house and install this stuff.
And it's just a massive shift. I mean, we are effectively watching the construction industry move from the Iron Age into the Polymer Age.
So let's start with that big picture. We see this massive market trajectory. in the research. The global PEX market is projected to nearly double, jumping from, what, $2.2 billion in 2025 to $4.2 billion by 2035.
Yeah,
That is not a small blip. That's a takeover.
it is. And to understand why that money is moving, you have to understand what this stuff actually is. PEX is just an acronym for cross-linked polyethylene. It's a type of plastic. But the cross-linked part, that's the secret sauce.
Right, I was reading about the standard polyethylene, like what a grocery bag might be made of.
Mhm.
It's kind of like long strands of spaghetti just lying next to each other.
That's the perfect analogy. They're separate.
But cross-linking ties them together.
Exactly. Imagine if you took those strands of spaghetti and tied little knots between them all, creating a net. That is what happens at the molecular level. It turns a standard flimsy plastic into something much stronger, much more temperature resistant, and much more durable under pressure.
And Uponor specializes in PEX-a.
Right, which is one specific way of making this net.
And the A matters, doesn't it? It's not just a grade, like getting an A on a test.
No, not at all. It refers to the manufacturing process. It's called the Engel method. See, there's PEX-b and PEX-c, which are made differently. They often cross-link the material after it's been shaped into a pipe.
Okay.
But PEX-a is made by cross-linking the polymer while it's still in its melted state. This creates the highest degree of cross-linking, around 85%, and that uniformity, it gives it properties that the other types just don't have.
Which is how they can position it as the premium product in the market.
Spot on.
And clearly the market is buying what they're selling. But looking at the drivers for this $4.2 billion surge, it's not just about new builds, is it?
No, not at all. The research points to a massive wave of retrofits. That's a huge factor.
So old houses.
Think about the housing stock in the US and Europe. You have millions of homes built in the 50s, 60s, 70s. They used galvanized steel, which rusts and constricts flow, or early copper that is starting to develop pinhole leaks.
So those systems are reaching the end of their biological lifespan, so to speak.
It's like the arteries hardening.
Yeah. And if you're a homeowner facing a repipe, you're looking for the path of least resistance. You don't want to tear your house down to the scuds if you can avoid it.
Precisely. And this is where the tech innovation comes in. Uponor isn't just resting on the pipe they invented 30 years ago.
The notes mention ServicePEX, which just rolled out in late 2024.
That caught my eye, too. It's specifically designed for large-diameter service lines, bringing water from the street to the building.
So they're not just thinking about the bathroom anymore.
They're thinking about the whole grid.
But what's even more interesting to me is the sustainability angle. I feel like plastic and eco-friendly usually don't belong in the same sentence.
It is counterintuitive, I get it.
We're conditioned to think plastic is the enemy. But the data here suggests otherwise.
Well, you have to zoom out and look at the life cycle. Think about copper. To get copper pipe, you have to mine ore, crush tons of rock, smelt it at incredibly high temperatures, and transport these heavy metal coils across oceans.
It's incredibly energy intensive.
Very. But Uponor is now producing PEX using renewable raw materials that, according to the life cycle analysis, slash the carbon footprint of manufacturing by up to 90%.
90%. That is a staggering number. That's not a margin of error. That's a revolution in production.
It is. And in commercial builds, we're seeing hybrid systems. They're mixing PEX-a with CPVC and other rigid plastic to handle different chemical environments. It's about using the right engineered material for the right job rather than just defaulting to metal because...
That's how we've always done it.
Exactly.
So we have a booming market. We have advanced chemical engineering, a sustainability argument. But I want to bring this down to the ground level. Let's say I'm listening to this and I've just bought a standard 1,500 square foot fixer-upper.
Okay, congratulations on the headache.
Right, thank you. But the inspection report comes back and says the plumbing is shot. I need to replace it. What does that experience look like with Uponor PEX compared to the old days?
Well, first, the shopping cart looks very different. You aren't buying 10-foot rigid sticks of metal that you have to strap to the roof of a truck.
You're buying coils.
You're buying coils. Uponor PEX comes in big rolls, red for hot, blue for cold, and white or clear for neutrals.
Which is a huge usability upgrade right there. Yeah. No more guessing which pipe burns you when you touch it.
It simplifies the schematic, exactly. Yeah. Then you have the manifolds. In a traditional system, you have a big trunk line with branches coming off it everywhere. It's a tree structure.
Okay.
With PEX, you often use a home run system. You install a manifold, basically a distribution center near the water heater. Every single fixture in the house gets its own dedicated line running directly from that manifold.
Oh, like a circuit breaker box, but for water.
Perfect analogy. If the kitchen sink leaks, you just flip a switch at the manifold and kill that one line.
But the rest of the house still has water. You can still take a shower while you fix the sink.
Exactly. It's a luxury you don't appreciate until you need it.
But I want to talk about the connections, the fittings. This, to me, is the most interesting technical difference. The research highlights the ProPEX expansion fitting. How does that work?
This is the game changer for PEX-a specifically. If you use, say, PEX-b or other generic tubing, you usually use a crimp fitting. You slide a metal ring over the pipe and you just crush it down with a tool. It works, but...
You're restricting the water flow, right? Because the fitting goes inside the pipe, making the opening smaller.
Exactly, and you're relying on that crushed ring to hold forever.
Okay.
Uponor's method is completely different. Because PEX-a is so flexible, you use a specialized expansion tool. It looks like a power drill with a cone on the end. You put a plastic ring on the outside of the pipe, you stick the tool in, and you pull the trigger. The tool actually stretches the pipe and the ring open.
So you're physically widening the tube.
You widen it just enough to slide the fitting in. Then you take the tool away. And because of that molecular net we talked about, the plastic desperately wants to return to its original size. It shrinks down, biting into the fitting with thousands of pounds of force.
So the pipe itself is the clamp.
Yes. And here's the kicker. As hot water runs through it over the years, that seal actually gets tighter.
No way.
It's a dynamic seal, whereas a copper solder joint is static. It's just sitting there.
That brings us to the property that the sources call the memory factor. This was the aha moment for me reading the notes. You have to explain this because it sounds like magic.
It's thermal memory, and it's unique to PEX-a.
So what happens if a contractor is dragging a coil around a corner and accidentally puts a hard kink in the pipe?
If that's copper, you're cutting that piece out and throwing it in the scrap pile. It's ruined.
Done.
Even with other plastics, a kink creates a weak spot, a stress fracture.
But with PEX-a,
With PEX-a, you stop. You pull out a heat gun, like a really high-powered hairdryer, and you just heat up the kink. As the plastic hits a certain temperature, that molecular structure resets. You literally watch the kink disappear and the pipe turn back into a perfect cylinder.
right before your eyes.
Right before your eyes. It heals itself.
What?
Then you let it cool and it is just as strong as it was before.
That has to translate directly to waste reduction and speed on the job site.
Right.
But magic self-healing plastic sounds expensive. Let's talk about the hard numbers. My 1,500 square foot house. Am I paying a premium for this tech?
Surprisingly, no. You're actually saving money, primarily on labor, but the materials are competitive too. Let's break down the material cost first. For that size house, you probably need 500 to 1,000 feet of tubing. PEX runs anywhere from, say, 40 cents to $2 a foot, depending on the diameter.
So the actual veins of the house might only cost, what, $500 to $1,000?
In raw pipe, yeah. Then you add the manifold, the ProPEX rings, the brass elbows for the walls. Your total material bill is likely landing between $1,500 and $3,000.
That seems incredibly reasonable for a whole house.
It is, but the real savings is labor. Think about running copper.
Oh, yeah.
You have to measure, cut, clean the joint with sandpaper, flux it, assemble it, and then stand there with a torch soldering it, then wait for it to cool.
And you have to do that at every single corner, every turn.
Every single one. And you're using an open flame inside a wood-framed wall. It's risky.
Right.
With PEX, you treat it like an electrical wire. You drill holes in the studs and just snake the flexible tube through the walls. You don't need an elbow for every 90-degree turn. You just bend the pipe.
So you're eliminating hundreds of potential joints.
Exactly. Fewer joints means less time and fewer potential leak points. A crew can repipe a house in PEX in maybe